There are two basic parts to any argument. There's a claim and a reason. But if we're going to know how to actually get into that argument, how to be specific, how to start with a larger topic but look for individual issues within that topic, and then look at how to describe that issue, we need to look at the different types of claims and the different types of reasons. As we're going to see later, a reason is another claim. It's a claim that supports the main claim. But any claim has the potential to be one of at least 5 different types of claims. Those 5 types we're going to call points of stasis. This goes back to the ancient Greek word that meant the placement or the setting or the particular group or category. It was a word that basically described the center of a fulcrum. If you imagine a fulcrum is the point that remains still, but other things move centripetally around it. This point around which all of the other elements move can be one of 5 different points. And the ancient Greeks and Romans distinguished 4, or at least 4. Later professors and scholars of rhetoric have added on as many as 9. We're going to concentrate on 5 in this class. And those 5 are the stasis of fact, which is also known as conjecture, the stasis of definition, the stasis of value or evaluation, the stasis of causation or consequence, and the stasis of policy. We'll learn the last 4 in a later series of lectures. Right now, I want to focus on facts. But if you've ever brought up a fact in an argument with another person, you probably realize that just pointing out that fact didn't necessarily lead that other person to the conclusion that you were hoping to lead them to. That is because facts are part of this chain of inferences, and these other types of stasis are other types of inferences. And whenever you see a fact, the first thing you want to do is define it. Say, what sort of category is this thing I'm looking at, or this new data? Where do I put that? How do I define it? And then, is one thing causing another, or could it cause another? And is that thing that it could cause a good thing or a bad thing? Is it better than other alternatives? And finally, what do I do about it? Is this something I should do? Is this something I should not do? Or do I want to argue that other people should or should not do something? That final claim, the saying that we should do something, is a policy claim. And that's the last point of stasis that we're going to come to in this class. It's actually one of the first ones that people think of when they sit down to write an essay. They say, okay, if I'm going to make a claim, I need to tell people they should do something. But we want to put that off. We want to at least recognize that before you can make a policy claim, tell somebody what they should do or should think, you have to establish all of these other points of stasis first. And the bedrock, the base of the pyramid is facts. You have to establish your facts before you can move any further. Now, there are a lot of definitions for facts. I'm going to go again to the Oxford English Dictionary, and we're going to use definition 8a, and this is the one you're going to use in any other college class when you talk about facts. There are sort of obsolete uses of the word fact. There's the common use of the word fact in everyday conversation. If somebody says that's a fact, that doesn't mean that the thing they're referring to is a fact in this sense. This is a particular thing, a particular truth, not just some large general truth, but a particular truth that is known by actual observation or authentic testimony. In other words, this is something that other people can see. This is data that you may have gathered that other people can verify. Or it's data other people have gathered that other people will have access to. And to understand this meaning of the word, or this use of the term fact, it helps to know what the opposite is. And the opposite of the fact is not a falsehood necessarily, but for this definition, it's opposed to an inference. An inference is something that can be true, but it's not something that's directly observable. It's something you do in your mind after you directly observe something. So you can base conclusions on an observed fact, but those conclusions themselves are not necessarily facts. Now I'm going to come back to this picture that my cousin Jeff took when he was living in Arizona, when he was working on something. I'm not sure exactly what he was working on here, but you see that there is either a rattlesnake or a lyre snake up under these cords, and once you realize the fact that that snake is there, once you see that visual information doesn't just sit there in your mind. You don't just say, oh, there's a snake. The end. your mind instantly generates several inferences, several assumptions about what that visual information means and what it could lead to and what you can do about that. So as soon as you see what looks like a snake, even if it's not a snake, as soon as that idea is triggered in your head, your mind automatically tries to define what it's seeing. In other words, you see the snake and you see that its markings resemble that of a rattlesnake or a lyre snake, and you know that both of those types of snakes are poisonous. If this visual information fits our definition of a venomous snake, even if we're misled and get that wrong, it's still, remember how the false positive pattern recognition works. It's better to overestimate the likelihood of a dangerous situation than to underestimate the likelihood of a dangerous situation. So I see that, I see those scales, I see those markings on its back. I know immediately it's a snake. I know it's probably going to fit the definition, the category of a venomous snake. And if it's a venomous snake, I know that a venomous bite will result in pain, injury, and possibly death. That's a causal recognition. So already I've recognized that there is a snake there, that it seems to fit the definition of a rattlesnake, which would be a poisonous snake. And that would mean that if I reached down there and got bitten, that would result in pain, injury, possibly death. And obviously pain and injury is a bad thing, something I would rather not endure. Now, if there was something really important I had to get down there that I was going to lose, or if my wife or daughter was close to that snake and I thought one of them was about to get bitten, then I'll have a value judgment to make. Is it better for me to reach down, grab that snake, and jerk it away from someone else who's in more danger? In which case I might still be risking something I know is value negative, but I do that in order to prevent something even worse happening. And I decide whether or not to do that once I've come to all of these other points of recognition. I recognize it's a snake. I define it as, it fits the definition of a poisonous snake. That means it could cause serious harm. And it seems like something that unless I have to reach down there, I don't want to do that. Then I automatically come to that final conclusion, which is I should not reach down there. Unless there's a reason that's worth the risk, then the policy I should adopt is not to reach down there. Seems relatively simple. It's something your mind does immediately, but that's kind of the point. We never look at facts by themselves. We always make all sorts of other conclusions based on that information that we take in. A computer, artificial intelligence, might be able to record facts without doing anything with it, but the human mind can't. The human mind, especially relevant facts, we immediately draw other conclusions based on that information. And those conclusions are called inferences. Inferences, again, we're distinguishing our use of the word fact as something you see or hear or you can validate, and other people can independently validate it. That is something different than the conclusions we draw from that, the interpretations we make from that information. Those interpretations, those conclusions, those are inferences. So an inference is the action or process of inferring, drawing conclusions from the facts or the statements of facts. And we'll come back later in the semester to distinguishing between inductive and deductive reasoning and premises that we use to get from facts to conclusions. But the inference is, but just think of the inference as the thinking that's left to do after you recognize the fact. So even if the fact is validated, you know that the fact is true, there's still some thinking yet to do. That is inference. So for example, if you go to the La Brea tar pits in Los Angeles, there are these excavated tar pits that have been there for millions of years. There are lots and lots and lots of mammal bones from millions of years ago, mammal species that are long since extinct. Things like saber-toothed tigers, ground sloths, these giant sloths, mammoth mastodons, and that sort of thing. The reason there are so many of these bones there is because these large mammals, these ungulates, things like woolly rhinos and bison, and in this picture a ground sloth, would get stuck in the tar pit. And then because it was stuck, it would look like an easy meal for a smilodon, like a saber-toothed tiger, or the large vultures and that sort of thing. So predators and scavengers would make their way closer to this trapped animal, which was going to be trapped there till it died. But then as these predators and scavengers got closer, they also got stuck in the tar pits. And so because of that, we have hundreds and hundreds, if not thousands, of dire wolves, of saber-toothed tigers, bison, this sort of thing. all of these bones, or all these fossilized bones, all there together at the bottom of these pits. But all of what I've just told you about how these bones got there, those are all inferences. The bones themselves and the placement in which they were found, those are the facts. The actual object, the actual fossil, and its location relative to the tar and the other bones and that sort of thing. That's the fact. That's independently verifiable. In some cases, you go to La Brea tar pits, that you can still see like an entire slab with all these bones sort of overlapping each other. And the ones that have already been dug up, the excavators are very meticulous about documenting, how far under the earth they were and how far they were from each other, oftentimes taking pictures or drawing diagrams about how the bones were laid out. That's the facts. Now, how those bones all ended up there, we infer. We see that, close to the bottom seem to be a lot of these large herbivores, and then there are carnivores on top of those, and then scavengers like vultures on top of those. So we can see a narrative, a sort of a story about one thing happening, then another thing happening, then another thing happening, that would have led to these facts being in the place that we find them, and in the arrangement that we find them. But we don't actually see that happening. We can't travel back in time and see this process happening. We have no idea how a smilodon, a saber-toothed tiger, would have hunted. All we can do is infer what probably happened based on facts that we can observe from big cats like lions and cougars and that sort of thing today, and compare that to what we see in the arrangement of these bones of these saber-toothed tigers from millions of years ago. So the object is the fact, the reasoning about how it got there. Those are inferences. And inferences can be true. So we don't want to... one opposing term to fact would be fiction, something that's not true. But in this case, an inference is something that's true, it's just not directly observable. And so once we see that fact, we start to define what we're looking at. We see the skull of what looks like a lion, but it has these much larger canine teeth, and so we define that as a smilodon. And a smilodon is not technically a saber-toothed tiger because it's not really related to the tiger; it's closer related to a lion. So if you're a zoologist, you're going to probably be more specific in your definition of that object and say, well, it's not actually a tiger; it's a lion. And what caused it to be there, defining it, exploring the possible causes for its location and all of that is all going to be inferences. Those are all inferences that are going to be set in motion by the discovery of this fact. And all of those interpretations, all of those inferences are going to be based ultimately on the facts, but they are not just the facts themselves, they are built on top of that. So the key points of this definition you want to remember in deciding if something's a fact or not is its particular truth. Don't focus on the word truth there. Obviously, we want it to be something that is true, but there are other things that can be true that are not facts. So a fact is a particular truth, and it's known by actual observation or testimony. And once we gather a lot of these particulars, we can then start to make larger inferences about larger rules. So when we go beyond the particular to try to say this sort of thing happens. So if we try to infer from those particular smilodon skulls and where they were found in the La Brea tar pits, we might make the assumption that this kind of thing probably happened a lot. We might then decide on a policy inference that would say if we want to find more mammal fossils from this time period, we might look at tar pits in other parts of the United States and other parts of the world, and we might find the same thing. That would be a policy inference. But to do that, we have to make a generalization. We have to realize when we look at one individual fact that if all we learned is that that one thing happened that one time, then we don't really learn a lot. It doesn't seem that relevant. We look for facts that we can use to generalize, to learn larger principles about the kinds of things that happen, the kinds of things we might see elsewhere. So a generalization is a kind of inference in which we take one instance and we say there's probably more instances like that. So generalizations are absolutely necessary. Imagine if you had to learn to open a door from scratch every time you came across a new door. So at one point you come across a door that has a round knob that you use to open it. And then another point you come across a door that has a lever handle on it. Then you come across another door that has you have to push in order to open it. This is something computer scientists find when they try to program artificial intelligence, program robots to open doors, that you can write a code or write a script to teach a robot to roll up to a door and open it, but then it comes across another kind of door and it has no idea that that's even a door. So it doesn't have the ability to take one specific instance and generalize from that. But notice that if I have those three types of doors, I have to forget certain properties of a door. What makes a door a door? It doesn't have to be a round knob. It could be a wide push-button latch. So that generalization means forgetting some of the specifics of a fact so that you can take what you've learned from one fact and apply it to other instances. But that can go too far. We can go too far that direction, forget too many of the specifics of a fact, and overgeneralize. So here's an example. We could say that California is the earthquake capital of the world. Now, you know probably basically what I mean by that. Okay, there are a lot of earthquakes in California. We hear more about earthquakes in California than maybe we hear about earthquakes in the rest of the world. So that is the kind of thing we might call true. But it's not the kind of thing we can call a fact in the sense that we've just defined, the sense of a particular instance. We could find specific facts about individual tremors and seismic events in California through the U.S. Geological Survey's website, where they have earthquake monitoring stations all over the place, especially all over California, and they'll tell us that about 2 hours ago there was a 2.0 magnitude 2-kilometer depth near Cobb, California. And about 7 hours ago, there was a 1.9 magnitude 9-kilometer depth near Brookings, Oregon. Each one of these seismic measurements is a fact. It's one you can verify. You can, if you had access to that seismography equipment, you could check that yourself. But that is not nearly the same thing as saying that California is the earthquake capital. Both of these have in common a general characterization of the state of California, which is that it's earthquake prone. But we've got very specific facts from the U.S. Geological Survey, and we've got a really vague generalization when we say that California is the earthquake capital of the world. Now, saying California is the earthquake capital of the world is too vague to qualify as a fact. But it's too vague to really be precise. We might find that somewhere else in the world has more earthquakes. But what does it mean to be the earthquake capital? Maybe Japan would be the earthquake capital, even if they had fewer earthquakes, because they actually spend more money on earthquake-proof buildings and bridges and things like that. Whereas in the United States, we don't do quite as much as they do to prepare for earthquakes. So what constitutes an earthquake capital? That term is really vague. It needs to be defined. And that's something we'll talk about later when we talk about the stasis of definition. But we also see that to say that 2 hours ago there was a 2.2 magnitude tremor in Cobb, California, that is a particular fact. It's not an overgeneralization, but that by itself doesn't really tell us very much that's relevant to us. Similarly, I might say that people in the South are fat. And you probably hear this on the news, or people will come from other states and say, I see a lot of fat people here in the South, and that probably takes you back a little bit and say, well, wait a second, I feel insulted by that. And they might say, well, I don't mean that as an insult, it's just a fact. Well, that too is not exactly a fact, it's a generalization. We come closer to dealing with facts and dealing with the facts of this issue if we say that while no state has an obesity rate less than 20%, the South has the highest prevalence of obesity, 31.2%, followed by the Midwest, 30.7%, the Northeast, 26.4%, and the West, 25.2%. 4 states, Alabama, Louisiana, Mississippi, and West Virginia, had an obesity rate or prevalence of 35% or greater. And this is all coming from data gathered by the Centers for Disease Control. And if you want to verify that data yourself, here's the URL. So it's very important that I'm citing my sources. I'm not just saying that I'm looking around and I'm making this generalization myself. I'm actually pulling specific numbers, but if I was to just make up percentages, you'd probably say, where did you get those numbers? If I'm going to be very precise, I need to show you where these precise facts come from. Citing your sources is extremely important. I'll come back to that in just a minute. But also notice when you cite the specific facts, It's not as big a deal if I said that even the 4 states in the South that had the highest obesity rate at 35%, that means 35% of the population counts as obese, but notice every state came up to at least 20%. So it's only about a 15% difference there. That's not as big as the generalization that people in the South are fat, as if that meant people in the North or people in the West are skinny. If I come too close to essentializing or to generalizing an entire population, then I really misrepresent what is going on. And of course, it's very relevant to realize that there's a higher obesity rate in our area than there are in other areas. We might want to learn what other areas are doing differently. But it's a gross mischaracterization to say that people in the South are fat and people in the West and in the North are skinny. I might advise you against buying products made by Burt's Bees, which is a company that for a long time advertised itself, represented itself as being very nature-friendly, environmentally friendly, the kind of company that wouldn't cause any environmental harm and certainly wouldn't do something like test on animals. But a while back they were sold to the Clorox company. And the Clorox company does test on animals. They test a lot of their products on things like rabbits and cats and dogs. And their own company statement says that they say that while the vast majority of our products reach the market without testing on animals, they also admit that, quote, at Clorox animal testing is a very rare exception, end quote. And that is from the Clorox company itself. So this would be an example of fact as testimony. I haven't gone there to verify that they are or are not testing on animals. If I did show up at a testing lab at any given point, I'm probably going to find them not testing on animals. Well, that doesn't mean that they never test on animals. So in this case, I'm depending on what they have said. And what they have said is a tacit admission that they do occasionally test on animals. Now, if I define animal testing as cruelty, and that is another inference that might be contested. But if I do define that, then I could say, well, it's basically true to say that if you buy Burt's Bees products, you're supporting animal cruelty. But there are a lot of other inferences that might not be so clear that get between the specific facts of Clorox admitting that they occasionally test on animals and that they are a parent company of Burt's Bees. Between that and saying that Burt's Bees and anyone who buys them supports animal cruelty. Those are two different things that depend on the same facts, but take those facts to different levels of generalization. So I put on the reading list educational video by the British BBC4 radio about the 20th century Austrian-British philosopher Karl Popper. And Popper's best known for defining science as a falsification task. Now he builds on definitions that go all the way back to Sir Francis Bacon in the 1500s. But what he points out is that science isn't just about confirmation bias. It's not just about starting with a hypothesis and looking for evidence that confirms that hypothesis. For all the reasons that we talked about last week, confirmation by itself is not very reliable. And what he insists is that if we're going to say anything is going to be scientific, it has to be something that can be tested. There's got to be a way that it could be potentially proven wrong. So don't confuse something being falsifiable with something being false. Falsifiable just means there is a way to prove it true or false. And the example that he uses is Marxism, and this is Marxism in the sense of economics. This causal theory that certain labor practices, certain management practices, especially as they were in the Industrial Revolution in the 19th century, that the way companies treated factory workers was going to lead to those factory workers rebelling against the wealthy factory owners. And so that was a predictive claim. This was supposed to happen. Because of these circumstances, this revolution would happen. The revolution never happened, and so rather than saying, well, maybe the claim, that causal claim was wrong, what 20th century Marxists said was, oh, well, it would have worked except there was this other thing in the way. And that's fine as a speculation, But you then have to go test that speculation. You can't just say, either way, whatever happens, our causal theory is right. You have to have a causal theory that actually predicts what's going to happen. And if it doesn't predict what's going to happen, it may not be totally wrong, but there's still something missing, and you can't say it's scientific until you figure out what that is. So Karl Popper made this observation about Marxist economic theory, which is it's not as scientific as it claims to be. Similarly, Sigmund Freud's psychoanalysis would attribute people's habits and thoughts in adult life to whatever they experienced as children. And if people said, well, I don't remember experiencing anything like that as a child, the Freudians would say, oh, well, you just repressed those memories. Well, that means that the psychoanalyst can just make up any kind of historical claim that as a child you had this kind of experience, and independent of any kind of verification. There's no way to falsify Freudian psychoanalysis. It's not testable, and for that reason, according to Popper, it's not science. And so, if we start with individual facts, they're not going to be relevant to us unless we can make generalizations. But we don't want to go so far with our generalizations that they're no longer testable, that they're no longer going to explain new facts that we come across. And if we come across new facts that don't fit that generalization, we call those anomalies. These are things that make us rethink the generalizations. The video uses the example of the black swan. As Europeans explored the world, they consistently came across swans that were white. In Europe, there are white swans. In Asia, there are white swans. In the Americas, there are white swans. And they generalized that, well, all swans are white. That's part of what it means to be a swan. Until they got to Australia. And all of a sudden, there are swans. They have all the exact same characteristics of a white swan, except they have black feathers. They have the same long necks. They have the same strange-looking beaks. And any animal of the same species can interbreed, so a black swan and a white swan could, have offspring. But they just had this new characteristic that didn't fit the category that people thought defined a swan. So a new fact, a black swan. In fact, the economist Nassim Nicholas Taleb has a book called The Black Swan, which is about things that we can't predict. And we have a tendency to forget that there are a lot of things we can't predict. And so that's why falsification is as close as we can get to proving something. We don't prove something by finding examples where it's true. We prove something by trying to find examples where it's false and just not finding them. That doesn't mean we never will. There could be more black swans out there we just haven't found that might make us rethink our theories. But the fact that we actually try to falsify our generalizations, that's the difference between science and what we're going to call a platitude. Platitudes are general descriptions, vague descriptions about the way the world is or the way things work that are true sometimes. You can think of examples when a platitude is true. But there are also going to be a lot of situations when that same platitude is not true. So a platitude is a phrase or a sentence that invokes familiar words and familiar preconceptions, but it doesn't actually make a precise and supportable claim. It doesn't make a falsifiable claim. They're impervious to falsifications, not because they're true, but because they're too vague to be tested. So they're not even specific enough to be false, to be disproven. They're protected from disproof. They're unfalsifiable. So unfalsifiable doesn't mean something's true. Unfalsifiable just means you have to take my word for it because it can't be tested. So if I say good things come to those who wait, you could probably think of situations in your life or the life of other people where they waited for something and then a good thing came to them. But you can probably also think of situations where you waited and actually missed an opportunity because you were waiting for it rather than actually going out and looking for it. Or you waited for something to happen to you rather than making that thing happen. And you might have consoled yourself by saying everything happens for a reason. But saying everything happens for a reason conflates a couple of meanings of the word reason. Does that mean that somebody had an intention that it should work out that way? Or is it just a causal explanation? Do I mean, when I say reason, do I just mean something caused it to happen that way? Does it mean that this thing that happened was for the best? Because not everything that happens is for the best. And saying everything happens for a reason doesn't bring me any closer to understanding what that reason was, so that I could maybe avoid a bad thing happening in the future. I can say that politicians lie, and of course you can think of situations where politicians have lied. But of course you can probably very easily find situations where politicians told the truth. You can pull a random person off the street and find that they have lied and that they have also told the truth. So saying politicians lie is an overgeneralization. If I say any two things have similarities and differences, that's true, but it's also not saying very much. And speaking of government, Ronald Reagan famously said in his inaugural address that government is not the solution to our problem, government is the problem. And he got a big round of applause at that point. Of course, that was his inaugural address. He was the executive head of the government. He was inadvertently identifying himself as a problem rather than a solution. He's not someone who's going to help us fix anything. But this kind of political rhetoric, this kind of partisan rhetoric, it's something that defines an attitude of one particular political party, in this case Reagan's, but it also ignores the fact that if the problem is getting from one place to another, then yes, governments pave the roads that we drive on, so government is actually the solution to that problem. If the problem is protecting us from foreign invasion, then the government creates the military. So yes, government is the solution to the problem. If it wasn't, Reagan wouldn't have wanted to be the head of it. So these kinds of platitudes can elicit certain emotions, and they can elicit a lot of approval, but they require the person hearing the platitude to do most of the work in applying the meaning. The people who would cheer Reagan when he said government is the problem were probably thinking of Jimmy Carter, the previous president that Reagan ran against. They're probably thinking of certain regulations they don't like. They were not thinking of regulations they do like. They were thinking of regulations that they felt restrained them, but they would approve of regulations that restrained other people whose interests might conflict with theirs. So all of these platitudes are removed from falsification. They're vague enough that you can make it mean whatever you want. But if you can make it mean whatever you want, then it really doesn't mean anything. But that's sort of the attraction of these kinds of platitudes. People make their entire careers just spitting out these kinds of platitudes to people who will buy their books and attend their seminars and this sort of thing. And you may post on Instagram and Facebook and on Twitter quote pictures that are inspirational because you can think of a meaning for that. It has a certain emotional valence. You can attach a lot of inferences to a particular quotation. But you can also probably find lots of examples where that quotation is totally wrong. The early 20th century motivational speaker Norman Vincent Peale wrote books like The Power of Positive Thinking and the book If You Can, If You Think You Can. Well, if you think you can fly, I don't recommend jumping off a building and trying to fly as you go down. A lot of people cause a lot of harm for themselves and others by thinking they can do something that they can't actually do. A lot of these platitudes express a good moral sentiment, like the famous Spider-Man quote, "With great power comes great responsibility." But of course, even within a Spider-Man movie, you have Spider-Man who has great power and takes on great responsibility, but then you have the supervillains who have great power and do not share that responsibility. So clearly great responsibility did not come with their great power. And a lot of our greatest leaders use these platitudes to motivate their citizens. Winston Churchill was very famous for his ability to rally the British population during the darkest days of World War II. When the German Luftwaffe was bombing London, people were frequently having to live in their basements or take shelter in the underground subway, the tube system, and sleep on the underground railroad tracks. Very discouraging point in their history, and Winston Churchill would get on the radio and make these public radio addresses where he would encourage the British citizens to keep their resolve, to not feel discouraged. And he would use a lot of these platitudes to encourage them to have that fortitude. And it worked, but that doesn't mean that those platitudes were facts. So when he says that courage is what it takes to stand up and speak, but courage is also what it takes to sit down and listen. In a specific situation, you might think of a good meaning for that makes sense. But you could probably also look at that and say, logically, those are two mutually exclusive statements. In the particular moment, that platitude might be open enough in its interpretation that you can make it fit that situation and lead to a certain outcome. But by itself, that statement is not a statement of fact. And it's not even necessarily a helpful generalization. But we hold on to these platitudes because they appeal to our need for closure. Remember, the need for closure is the recognition that there's something we don't know or some problem we have and we don't have a solution to. And we want to answer that question as quickly as possible or solve that problem as quickly as possible. But even though we look for the really quick and easy answer, we tend to forget how easy that answer was and potentially how superficial and unhelpful in the long term that answer might be. So we seize on that first answer available, but then we freeze on it. We want to use that answer for lots of other things, even though it might not be a very good answer for other situations. But that need for closure leaves us vulnerable to the illusion of knowledge, the illusion of explanatory depth. It leads us to think we know something we don't actually know that well, and that could have very negative consequences when we try to apply knowledge that it isn't actually very accurate. And that's why abstract knowledge is more comforting, because it's vague enough that I feel like I could apply it to lots of different situations. But if it's not falsifiable, it might be bad knowledge. It might be an answer that worked great in one situation, but is going to be terrible in a different situation. But we resist that. We don't like people telling us that our answers aren't very good or that they're not as good as we think they are. Another way to describe a platitude is BS. And I'm going to say BS just in case you're listening on YouTube with kids at home. BS, you might not expect, has actually become a philosophical term. Well, the philosopher Harry Frankfurt wrote a book called On BS. And he did so because he wanted to point out a problem in all human discourse and all human knowledge, which is there is something that's different than saying something that's factually true or a complete lie. We're often in the habit of speaking from the illusion of explanatory depth and not being able to catch ourselves when we put out a platitude or some sort of false knowledge in place of what we are confidently sure is real knowledge. That is not a lie. If I believe something that's wrong and I continue to use it and I don't try to verify it, then that's just as big a problem, according to Frankfurt, as if I was deliberately lying to someone. Because the end result is the same. I'm spreading a falsehood, and it doesn't really matter to the person I deceive whether or not I was also deceived by this falsehood. So that's how he defines BS. BS is when you say something without really knowing what you're talking about. And moreover, it's when you don't know what you're talking about and you haven't bothered to check to see if you know what you're talking about. He says, someone who ceases to believe in the possibility of identifying certain statements as true and others as false can only have two alternatives. I should point out that he's not just saying that this is only true for people who don't believe in truth and falsity, don't believe there's any such thing as truth. This is anyone who's in a situation where they're not able to actually verify something, or if they just don't think verification is necessary. They have two alternatives. The first is to desist both from efforts to tell the truth and from efforts to deceive. This would mean refraining from making any assertion whatever about the facts. In other words, if you don't know what you're talking about, don't say anything, or say that you don't know what you're talking about. The other alternative is to continue making assertions that purport to describe the way things are, but that cannot be anything except BS. Thus, the production of BS is stimulated whenever a person's obligations or opportunities to speak about some topic are more excessive than his knowledge of the facts that are relevant to that topic. In other words, when we have the opportunity to speak, we usually take it, even if we don't really have anything good and verifiably accurate to say. And you can probably think of lots of situations like this. You can probably think of situations where other people have done this to you. You may not be able to think of so many times when you've done that to other people, but I bet your friends can. We all do it. So having the opportunity to speak sort of creates this need to speak. And the need to speak can be fulfilled without actually having substance to what we're saying. And that observation led to the study that you read about for today. There's a website called The Wisdom of Chopra, that plays on the writings and speeches of the self-help guru Deepak Chopra. But this website randomly generates sentences. They're all grammatically correct, but the subjects and verbs of these sentences are selected at random from a bank of subjects and verbs, and that means that the sentences they put together could potentially have the possibility of being true, but they don't necessarily mean anything. They don't refer to something outside of that algorithm. For example, a single particle is the ground of incredible actions. That sounds like the kind of thing you might see in a motivational quote pick. I can interpret that to mean that, well, something small could lead to something big, and this matches the sorts of platitudes we've heard from motivational speakers, from Tony Robbins to Norman Vincent Peale. But that's also not exactly what the sentence is saying, and if we're going to be precise about what a particle is, are we talking about like an atomic particle? In which case, it can't actually be the ground. It can be part of the ground on which an action takes place. But what kind of actions are we talking about here? Even if we were talking about, say, splitting the atom, obviously that would cause an incredible action. But in that situation, the particle wouldn't actually be the ground. It might spark something, but other particles would constitute the ground. Ground here has to ultimately be metaphorical. It's something underneath the action, something that is spread out beneath this ongoing action. Another example, attention and intention are the mechanics of manifestation. We can insert meaning into this sentence. I know what attention is, and I know what an intention is. And mechanics is something, just the driving force or the components that lead to an outcome. And a manifestation is an outcome. So a manifestation could be said to have mechanics. It could have parts. It could have processes that cause something to go from being latent or hidden to being manifest. But whose attention and whose intention? And are these really the mechanics of that manifestation? Wouldn't they be the things that set those mechanics in motion? Well, maybe, maybe not. It's not specific enough to be refuted. It's unfalsifiable. And on the reading list for today, you read about this study. You read Jesse Singal's article about this study, where Gordon Pennycook and his colleagues wanted to use the wisdom of Chopra quotes, those specific quotes, among others, to see just how responsive people were to these sentences. These sentences that seemed to say something, but actually didn't say anything specific. And it's not just any kind of BS. There are other kinds of BS, like when you make a very specific factual claim that turns out to not be true. But what they wanted to focus on was what they call pseudo-profound BS. Profound meaning it has so many meanings, or the meanings are so vast. But that should be a cue that its profundity is going to conflict with that definition of fact that we were using at the beginning. A fact being something particular and observable. Something that's profound is going to be not particular. It's going to have so many meanings that it could mean anything and therefore not be definable. They say, here we focus on pseudo-profound BS, which consists of seemingly impressive assertions that are presented as true and meaningful, but are actually vacuous. Vacuous meaning like a vacuum. There's nothing inside. Detecting is not merely a matter of indiscriminate skepticism, but rather discernment of deceptive vagueness and otherwise impressive-sounding claims. In other words, they're not looking to see if people are just randomly skeptical of everything. If it was a very specific and testable, falsifiable claim, you might say, okay, well, if you've done the research on this, I'll trust you until I have reason not to. But what they were hoping was that people would see these statements and realize those statements don't actually say anything. And in writing about this study, Jesse Singal discriminates between a lie and BS. So he would be lying if he said, I'm typing this article on a typewriter rather than a laptop. If he wrote that, you wouldn't know if he's telling the truth or not, but if you were there able to witness, or even if you got him to tell the truth later on, you would be able to find out that that was a lie. But if he told you that some of the components in my computer were manufactured in Taiwan, that might actually be true. He doesn't know that to be false, but he also doesn't know that to be true, so it constitutes BS. But he also wants to distinguish between that and figurative language, poetic language, metaphorical language. We depend on metaphors all the time, more than we realize. Like when we say something is vacuous, that means it's like a vacuum. a word doesn't take up space, it doesn't contain anything, but we use that container metaphor to talk about a word containing an idea, but that's just a metaphor. So he points out that the quotation, "A river cuts through a rock not because of its power, but its persistence." That's figurative language. You can infer meaning in that a lot more easily than the interdependence of oneness grows through the door of knowledge. In the figurative language, you see that the principle that this metaphor is pointing to is the fact that a river can cut through a rock slowly, gradually, by repetition, water constantly eroding through the sediments that compose that rock. So it's not a single moment, a single blast from this river. It's this slow, gradual persistence of erosion. It makes sense in a figurative, metaphorical way. But the quotation that follows it, "The interdependence of oneness grows through the door of knowledge," this does not have a metaphorical tenor. It doesn't have an object in nature that we can use to compare to something else. Interdependence means that two things depend on each other. How can oneness be interdependent? That means oneness would have to have a duality. It would have to be two-ness to the oneness so that one part could depend on the other. So you can't have an interdependence of oneness. And what does it mean to say that it grows through the door of knowledge? Is it like a plant growing through a door? And does a plant growing through a door really go anywhere? It's still stationary. Doors are things that, separate one realm of movement from another realm of movement, but the plant isn't actually going anywhere. Maybe a foot or two through this door. But these words trigger these emotional connotations. Interdependence is something that reminds us of being connected to other people. Oneness may also make us think of being connected to other people. The door of knowledge sounds like a checkpoint in this quest to learn more knowledge. But notice that the kind of knowledge we're learning here is not something we can actually do anything with, even if it does make us feel good. And Pennycook and colleagues say that the concern for profundity reveals an important defining characteristic of BS in general, and that is that it attempts to impress rather to inform, to be engaging rather than instructive. In other words, people who have the opportunity to speak, as Harry Frankfurt said, having the opportunity to speak triggers BS when our opportunity to speak outruns our knowledge of what we're talking about. Remember that things like confirmation bias, things like confidence in a false opinion, can actually lead to our elevated status. If I make an argument of persuasion and I'm wrong, but I persuade other people to believe me, my social status goes up. Unfortunately, our knowledge status goes down because now we all share this falsehood. Whereas when I make an argument of inquiry, I might admit publicly in front of all these other people that I don't know something. And that takes a high degree of modesty. But that modesty, that recognizing that, okay, my social status is not worth being wrong, that can actually lead us to be more accurate. And what they're finding is BS, which is very closely connected to the illusion of explanatory depth, confirmation bias, arguments of persuasion, all of these tactics that our minds use to make us feel good, to feel like we know something, but actually lead us further away. They all share this characteristic that they are trying to impress other people rather than to actually inform other people. So just from what we've read about the Pennycook study, it's tempting to say something like, in today's society, people believe a lot of BS. And we could say that, but that's not what they do. That's not what this study does. Notice the way this study works is not just making a vague generalization. And this is where academic research distinguishes itself from arguments of persuasion. If this is going to be an argument to inquire into reality rather than just build up the status of a few researchers, if the goal is not just to persuade and to impress, but to actually understand, then we have to devise a form for proving our case, gathering our data, gathering our facts, or at least the descriptions of those facts, and making them available to other people, especially to other experts in the field who would know how to understand those facts. who would know what inferences were validated by those facts and what inferences were not validated by those facts. So as much just raw data and details that might seem irrelevant to the rest of us, as much of that kind of thing as Pennycook and his co-authors can put in this article, the better, because this article is going to a peer-reviewed journal where other psychologists, other people who focus on judgment and decision-making, that is the article, that is the journal that they've published this article in, people who have done a lot of research on these same sorts of decision processes are going to look at this data, and they're going to be very critical. They're going to want to see as much specific facts as possible before it gets turned into generalization, before it gets turned into inference. And then they're going to follow along with the inference process that Pennycook and his co-authors make, and they're going to see how Pennycook and his co-authors got from these specific numbers, from these questions, to the conclusions that they come to the generalizations they finally do make in the end. This is what sets peer-reviewed research apart from general research, including the Jesse Singal article that you read about this. The Jesse Singal article was written for a general audience who may not necessarily be experts in judgment and decision-making sciences. But he's translating this. He's just cutting to what we might consider the relevant part. He's leaving out a lot, but notice how much data the Pennycook study actually contains in it, all the way down to the individual quotes, the individual people are being shown, and then the numbers of how many people are rated the quote one way as opposed to another. This is why peer-reviewed research is going to be a much better source for facts as well as generalizations when we are looking for sources ourselves. And I'm going to talk about why that is and how that process works in the next lecture.